Hi guys, I hope you're good and I hope you're well. Welcome to TS Tutoring, and today we're covering acid and bases and the reaction of acid and bases, right? So this is the introduction of acid and bases, whereby we want to define what is an acid and what is a base. These are the basics that you should know before we continue with this topic, right? So an acid and a base, they have two definitions. There are scientists who came up with these definitions. Well, here on my paper, I wrote the definition based on a scientist named Bronsted-Lowry, right? So in his theory, he named an acid and he said that it's a substance that donates protons, right? And we know that a proton is a hydrogen ion, right? An H plus, right? And then when he named the base, he said that the base, it's a substance that takes up protons, right? It accepts protons. So also H plus, right? So the other person, Arrhenius, in his theory, he said that an acid is a species which increases the concentration of hydrogen ions in water. And a base is a species which increases the concentration of hydroxide ions, right? The OH ions in water. So those are the two definitions that we deal with. So in this session, we focus on the Bronsted theory that the acid is a substance that donates protons, the H plus, while the base accepts those protons, right? So I wrote a reaction here between hydrochloric acid and ammonia that forms the ammonium ion and the chloride ion. I want us to identify, based on these definitions, which one is an acid, which one is a base, and looking at our product, what did we form? So now, this is a reaction of an acid and a base. According to this definition, and when we look at this reaction, what happened? Well, let's look at this side first, the reactant side. We have HCl, hydrochloric acid, and ammonia. And let's look at the product. We have ammonium ion and chloride ion. This chloride ion comes from here, right? So if we look at it, the H, we know that a Bronsted-Lowry acid donates the protons. This is a proton. When you come this side, the Cl is alone. That means this proton was donated to something, right? And if we look at ammonia, it had 3 protons. When we look at this side, it now has 4 protons. That means ammonia accepted a proton from HCl, right? Therefore, HCl becomes our acid. It gave this proton here that I cycled to ammonia. And ammonia served as a base, according to the Bronsted-Lowry. It accepted that proton. What did it form when it accepts the proton? The hydrogens were 3. Look at it. Now they are 4. NH4. N is still 1, 1. So we formed ammonia, ammonium ion. And because the Cl was joined to the H, now the Cl is alone, right? So we identified our acid and our base in this reaction. Now, let's look at other reactions too. Let's see if we can identify an acid and a base. Now, looking at this reaction, we had 3 protons here, and now this side, we have 4 protons. It means now, this must have been a base. It accepted the proton. And now OH is alone here, but here, there was another hydrogen. So it means that this water molecule served as an acid. It donated the proton to ammonia, and ammonia formed ammonium ion and hydroxide ion, right? You look at which one gained the proton, which one lost the proton. We know OH, when it combines with the H, it forms water. You understand? So we definitely identified our acid and our base. Let's look at the last example so that we can continue and see if we can identify which one is an acid, which one is a base, right? So let's say we have, let me write this reaction. So this is number 2. Let's look at number 3. Let's look at acetic acid. CH3, you know acetic acid, right? Your vinegar. It reacts with water, it's a liquid, to form H2O plus ion in aqueous plus CH3COO negative in aqueous. Now, let's identify which one is an acid, which one is a base, right? Now, based on what happened, we had a proton here, but now we no longer have a proton. That means we lost that proton. Here we had 2 hydrogens, now we have 3 hydrogens. This water molecule must have accepted the hydrogen, this hydrogen, from acetic acid. So acetic acid must have been our acid, this one must have been our base. Because acetic acid, if we look at it, it gave this hydrogen here. And if we look at its part, this side, there's no hydrogen. It lost the hydrogen, hence the negative ion. The water accepted this hydrogen, therefore it had 3 hydrogen and oxygen here, forming this cation of ours, right? So water is the base, acetic acid is an acid, right? We identified. Now I want us to talk about something which you will see, it will come up in your maybe they might ask you to define it. An amphoteric substance, right? Now this substance, it can react as an acid or base. You see? So an amphoteric substance can act as an acid or base. And the most example of an amphoteric substance, or the normal or usual one that we always see, is H2O, right? Water can act as a base or as a acid. Here it acts as an acid. You see it donated the hydrogen to ammonia, but here water acts as a base, so that's an amphoteric substance. That's what I wanted to talk about. You will have to define it, right? Now let's move on. Now let's talk about the reactions. What happens when an acid and a base reacts, right? That's what we want to know, right? So according to the theory, when an acid and a base reacts, a neutralization reaction takes place. What do we mean by neutralization? We mean that we are forming a salt and water when a strong acid and a base react, right? This is an acid-base reaction. So a reaction between an acid and a base is known as a neutralization reaction. So it means that salt and water is formed when an acid and a base reacts. These are our product. So the first reaction we want to look at it's a reaction of an acid and a metal hydroxide. By metal hydroxide, we talk about things like sodium hydroxide. Sodium is a metal and joined to the hydroxide. Also potassium hydroxide. Potassium, we know it's a metal. Let's look at the first example. HCl in aqueous reacts with sodium hydroxide, right? So a metal hydroxide, sodium is a metal, hydroxide is the OH. What we form is H2O, as the theory says, water plus what? Plus a salt, sodium chloride, isn't it? In aqueous. That's what happened here. So what happened is that the H here joined with the OH to form water. The Cl joined with the Na to form sodium chloride. So this is our product, water and salt. Which one is our acid? This is an acid. This is a base. So when an acid and base reacts, they form water and salt, right? Let's look at another example. Let's say HBr, hydrobromic acid or bromic acid in aqueous with reacts with potassium hydroxide in aqueous. They form water. So the product is just simple. You know it's water and your salt. So KBr, right? So what happened here? We know that this H will join with this OH to form water. The K, the metal, will join with the Br to form our salt, right? Potassium bromide. So this one is our salt, which is potassium bromide, and water, the base, which is the metal hydroxide, and the acid. So this is the reaction of an acid and a metal hydroxide. They always form a salt and water, isn't it? So now you understand the neutralization reaction. An acid and a base react and then they form salt and water. There are other reactions, right, of acids and bases, right? Now here we looked at acid and a metal hydroxide, isn't it? So it will always be like this, right? Let me get another page. So this is an introduction to acid and bases and their reactions. Now I want to look at the last example or the last type. That one was an acid and a metal hydroxide. This one is an acid and metal oxide. I'm trying to keep the video short, at least 15 minutes. So still, when an acid and a metal oxide reacts, we still form salt and water. Let's look at this reaction. So a metal oxide, that means we need a metal and oxygen there. So let's look at 2HCl in aqueous reacts with this one, sodium oxide, in aqueous to form H2O and 2 sodium chloride. So you see, we know sodium chloride is our salt, this is our water, these are our products. Now a metal oxide, sodium is a metal, oxide we mean there's oxygen there. This is an acid, we know it. So these are the other common type, right? Now the other one, another example, let's say 2HBr in aqueous plus magnesium oxide. So magnesium, we know it's a metal oxide with oxygen. The product will always be water and what? A salt. Now our salt should be the magnesium, the metal, and this halide. So it's gonna be magnesium bromide, isn't it? So water is a liquid, this one is an aqueous. So when an acid reacts with a metal oxide, we form water and salt too. It's the same. When an acid reacts with a metal hydroxide, still form water and salt. Here acid with metal oxide, we still form water and salt. These are our products, right? Water and a salt, isn't it? So these are the basics I will do another video. 15 minutes is up, and then we continue with acid and bases. But this is what I wanted to talk about, right? When an acid reacts with a base, a neutralization reaction takes place, in which the product is going to be a salt and water. The standard is like that, it will never change. And an acid, it's a proton donor, while a base is a proton acceptor. An amphoteric substance is the one that can act as a base or a acid, which in this case is water most of the time, right? When we have types of acid and base reactions, we have an acid and a metal hydroxide forming salt and water, and we have an acid and a metal oxide forming salt and water. Another type that we need to look at, which we'll do on the next video, is going to be an acid and a metal carbonate, right? The reactions. And then the last one will be redox reactions. So thank you for watching, and I hope you'll enjoy this video.